Hey, so here's the thing. Once in a while, we just gotta conserve class time by having to do a little bit of homework. I try not to do this, but when I ask you to read about something prior to coming to class, I'll do a screencast like I'm doing this time here, just so that for those of you who are like me, are more auditory learners than visual learners. So I'll always give you the the slide presentation if you just prefer to look at it that way if you're more of a visual learner. Okay, anyway, let's get going. In tomorrow's class, well, next class, Monday's class, we're going to be doing our first experimental design. We have a lot of experiments we do in the course of the year. It's always something that's assessed on our each of the tests of the year, and I want you to be successful with it. And it's kind of fun. I think most of you already know a little bit about this because it's something that KS has been emphasizing throughout your education. Even if you didn't go to KS, it's something that most science teachers emphasize. So let's just get going. This is Mr. Sampson's take on. Okay, here you go. All right, so the basic approach to most experimental designs is you're going to make changes to one variable, a variable being something that can have different values, okay? And the one that you have some agency over, some ability to make decisions about ahead of time, you can decide if you can make it bigger or smaller. That's called the independent variable. And then there's the dependent variable, which is going to change in response to whatever decisions you made with the independent variable. Okay? And then we have what's called the control variable. Now, the control variable is something that you're going to try to keep constant. And that's what I really want to focus in on, because I think a lot of my students have a pretty clear idea. Like, the independent variable is one I'm going to make changes to, I'm going to make decisions about. The dependent variable is one that's going to change because of that, right? But controlled variables are ones that sometimes students get confused about. And the idea is this. Think of it this way. I, in my experiment, want the changes that occur in the dependent variable to be completely attributable to the changes I made in the independent variable. That way I know how the independent variable affects the dependent variable. I know how these two variables are related. But in most cases, there are other variables that could affect the dependent variable. And if that's the case, I don't want their influence being exerted on its values. So I keep them constant. So don't think of a control as anything I could keep the same. I'm going to use the same table. Well, the table's not going to affect the rate of productivity in my experiment, so it doesn't matter. Anything you think could make a difference in the dependent variable other than the independent variable should be controlled. Okay? And we'll work on that a lot this year. You'll get the hang of it. So in this class, the independent and dependent variables are almost present in the prompts that I give you, whether it's in a daily activity or in your tests. So here's my advice to you. Just read the prompt and then ask yourself which variable, first of all, the variables will be present in the prompt, guarantee you. When you read that first sentence of the prompt, there will be two variables in there. You just want to ask yourself, which of these variables could I make changes to? And which of these variables would be affected by the changes that I made? That would be your dependent variable. All right, so let's just take a look at an example, okay? So let's just say I said, I want you to design an experiment to determine the effect of temperature on the productivity of aquatic plants. So the first step you're going to do is you're going to identify the two variables present in the prompt. Well, when I read this, I see design experiment to determine the effect. Okay, temperature is something that I could measure or change, okay? And productivity is something that could be measured and could change. So those are my two variables, okay? So I know I have two variables here. I know that I have, how do I do this here? I know I have, why is this not working? Oh, there, I have temperature and I have productivity. Those are my two variables. Now the next step is determine which of these would be your independent variable. Well, the independent variable is the one that you would be able to make changes about ahead of time. You could say, I want to make this higher or lower. I want more or less, okay? I'm going to change it a little or a lot. Well, in this case, the one that you can clearly make decisions about is temperature. You can't really decide how productive a plant is going to be. So therefore, the temperature would have to be your independent variable, and that means that the other variable, in this case productivity, would have to be your dependent variable. So your experiment is going to be to change the temperature and see what it does to productivity. Now here's the part that I need to work with you this year, because historically my students for the last 38 years have struggled with this, okay? And I get it, it's a little bit challenging. You have to identify, usually I want you to identify two or more controlled variables. Now we say, remember, our dependent variable in this case is productivity. I only wanted to change because of my independent variable, which is temperature. So I asked myself, what other than temperature could cause a change in productivity? Well, let's think. What could be that? Let's see. It could be maybe the species of aquatic plant, right? Like some plants are just, they produce more biomass per day than other ones, okay? So I don't want to use species A in warm water and species B in cold water. How much light they're exposed to, right? Clearly, the more light you're exposed to, the more productivity you can engage in. How about the starting mass of each sample? If I have a lot of biomass, a lot of, of chloroplasts present, I'm going to have more productivity. So that could also affect it. The water chemistry, right? If I start off with a lot of carbon dioxide in one and not much in the other, then you need carbon dioxide to engage in photosynthesis, so that could affect. So these are just 4 examples of things that could affect the productivity of the plant other than temperature. So I want to try to make sure they're the same between all the samples that I'm examining here. Oops, touch this one here, Samson. Come on. Okay. All right. So I just said this, so I'm not going to do this again. Okay. Sorry about that. So now the next thing is decide how you're going to change and measure your independent variable. You need to be very specific. You need to be realistic. So, okay, I know I want to change temperature. How am I going to do that? Okay. Specifically, how are you going to make changes to this? Okay. So what I could do is I say, well, I'm going to change the temperature by placing containers of aquatic plants. One of them, the container is going to be placed in an ice bath, so it's close to 0 degrees Celsius. I'm going to place one at room temperature, which is about 20 degrees Celsius. And I'm going to put another one in water that's on a hot plate, which let's say is at 30 degrees Celsius. Okay, so now I've got 3 different temperatures to compare. That should be enough, okay? And how am I going to measure temperature? Duh, I'm going to use a temperature probe. Well, maybe I say duh. Okay, so in this class we have access to computer software, so we have a thing called a temperature probe. You probably used it, but you'll use it quite a bit this year. So the next thing is you got to decide how are you going to measure your dependent variable. Okay, so I said my dependent variable is productivity. There's lots of different ways I can measure productivity. I can measure by chemical changes in the water, but probably the easiest and most reliable is just changing biomass. Okay, so here's what I'm going to do. I'm using electronic balance to find the starting mass of each plant. Let's just say they were each start off at 10 grams. And I'm going to use it again at the end of a given time period to see how much change there was. Whichever one has more biomass at the end must have engaged in greater productivity. Because remember, the best way to measure NPP, net primary productivity, is by measuring biomass. Now, how about control samples? Okay. Let's just talk about a control sample. So a control sample is different from a controlled variable. And not every experiment requires the use of a control sample, but many of them do. And this is something that's more common in environmental science and biological sciences than it is in the physical sciences like chemistry and physics. So let's just zoom in on this a little bit. Okay, so a control sample is basically a sample in which there's been no treatment administered. And the purpose of it is to have a basis of comparison. Like, what would happen if I didn't do anything? Okay, that's the idea of a control sample, because maybe things are going to change and it has nothing to do with what I did to my independent variable. So here's an example of it. It may not be the best example, but it's one that came to mind right now. So a study is done to determine whether pesticide A or pesticide B is going to have a greater negative effect on soil nitrogen. That's a pretty common environmental science kind of experiment to do. Okay, so my independent variable, the thing that I have the agency to change, is the type of pesticide used. The dependent variable in this case is going to be the change that happens in soil nitrogen. All right, so how am I? And there's different ways. There's nitrogen tests that you could use, but I'm going to look at the change. Okay. My controlled variables, in other words, what else could affect soil nitrogen other than the type of pesticide? Well, the type of plants that I put in the field, as a farm, the spacing between the plants. If you have a lot of plants, they're going to take more nitrogen out of the soil. How much water I put on it, because I guess water could leach that nitrogen out of the soil. All right, so those are all things I'd want to be the same between pesticide A and pesticide B. But my controlled sample would be, you know what? I'm going to take a field and I'm just not going to do anything to it. I'm just going to leave it be. I'm not going to put any kind of pesticide in at all. And I'm just going to see like how much does the nitrogen change in this field here. So that's the idea of a control sample. It's just something I could compare to see, well, what happens if you don't mess with it at all? Okay, now, finally, I'm going to end this here. So often, but not always, you'll be asked, because it takes time, you'll be asked to describe how to conduct an experiment. You should be prepared to do this, okay? And I'm sure you've done it before. All right, now, by the way, I'm not going to have you turn in lab write-ups in this year. All your grades in this class are going to come from the tests that you take during class. But sometimes during the test, I'm going to ask you to do a lab write-up. So what you're going to do is you're going to first use a bulleted list like I did here. Okay. First, you want to describe, you want to identify what the independent variable is, and you want to say how it's going to be changed and how it's going to be measured. Then you're going to describe what the dependent variable is, and you're going to say how it's going to be measured. I should have said how it will be changed. I cut and pasted. I shouldn't have done that. Okay. Then you want to indicate which variables are going to be controlled. You know, what things are going to be kept constant so that they don't interfere with my acquiring the necessary data. And then you want to indicate how many times you're going to change your independent variable and then check in on your dependent variable. That's all you got to do, okay? So anyway, thanks for watching this. I'm sorry it took so long, but I want to do as many experiments as we can. I want you to be successful when you do them. I don't want this to be the thing you have to like reassess all the time. All right, guys. Well, thanks. I'll see you in class on Monday.